Welcome, curious minds, to another deep dive. Today, we're plunging into something really fascinating, a new development in the world of large language models. LLMs. We all know how powerful they can be, but, well, you probably also hit those frustrations, the infamous hallucinations.
Oh, definitely.
Or when they give you information that's just plain old, or sometimes they just aren't as quick or sharp as you need when you're looking for complex answers. So we've really dug into some compelling research, some articles on this novel approach called RAG-R1. It seems to promise tackling these exact issues head on. Our mission today: let's unpack how this framework helps LLMs get, well, smarter, faster, and frankly more reliable, basically giving you a shortcut to understanding some pretty cutting-edge stuff.
Exactly. The fundamental challenge really is that the knowledge inside these LLMs, it's static. It's frozen at a point in time. So when you ask them complex questions or things happening right now, that limitation, it really hurts their reliability. Now, traditional RAG methods, Retrieval-Augmented Generation, they try to pull in external knowledge.
Right, that was the first attempt to fix this.
Yeah, but they've hit their own hurdles. Like, they can be super sensitive to prompt engineering. You have to phrase things just so.
Yeah, finicky.
Very finicky. And sometimes, maybe worse, they just end up memorizing specific answers they found, which means they can't really, generalize that knowledge to new situations.
Okay, so even as things got better, these core problems stuck around. And from what we're seeing in the sources, even the newer egg approaches, the ones using reinforcement learning, they still wrestle with, stable training. And this major bottleneck, the single query mode, which means, well, they ask one question, wait, get an answer, ask another.
That's right, one at a time, which, as you said, can be agonizingly slow.
And limits how much info they get back, I bet.
Precisely. And this is really where RAG-R1 starts to look, well, quite innovative. So to tackle these, deep-seated problems, RAG-R1 uses this novel two-stage training approach. Think of it like teaching a really bright student who's just maybe a bit disorganized. The goal is to get the LLM to strategically use both its own internal knowledge and external information, kind of weaving them together during its reasoning process.
To make sure the answers are actually right.
Exactly. Better reasoning, correct answers. That's the aim.
Okay, that sounds like a smart evolution. So what's step one in this new training regime? How do you start teaching it this?
Right. So the first stage is called format learning, supervised fine-tuning, SFT for short.
SFT, got it.
Think of it as teaching the LLM how to think and search strategically. It's not just giving it facts, it's about instilling a discipline in its process. The model gets trained to respond in a very specific format. Think, then search.
Think, then search, okay.
Yeah. For example, it gets explicit instructions, something like, you must conduct reasoning inside think tags every time you get new info. If you realize you're missing something, call a search engine using search, query search. You'll get results back between information tags. If you don't need more external stuff, just give the answer in answer tags.
Wow, that's very structured.
It is. And this structure, even for a simple query like Beijing, it's crucial. It helps prevent the model from just making things up or going off on tangents.
So fewer hallucinations, more relevant details.
Exactly. It makes the LLM more grounded, more reliable right from the start. This SFT stage basically lays down a really strong foundation, a stable kind of cold start for what comes next.
Okay, that think then search structure sounds incredibly disciplined. Stage one gives it that framework. But thinking strategically is one thing. Using external info dynamically, that feels like the next level. How does RAG-R1 push it to actually act on that thinking?
Precisely. That brings us to stage 2, Retrieval-Augmented Reinforcement Learning, or RL.
RL, right.
So here, the model's reasoning isn't just tweaked, it's significantly enhanced. It learns to dynamically go out and fetch external knowledge when needed to get accurate answers. And a really key detail here is how they select the data for this stage. They specifically pick questions that the model got wrong back in the SFT stage.
Ah, okay. Focusing the learning.
Exactly. But importantly, questions that are actually solvable. So it's learning from its mistakes on things it could get right. Now, during this RL process, there are some important technical bits that help keep it stable and effective because, RL for LLMs can be tricky.
Yeah, I've heard that.
So for instance, they use something called a retrieval masked loss. What this does is it makes the system focus only on optimizing the words the LLM generates itself, and it specifically ignores the information that was just retrieved.
Okay. Why do that?
It helps stabilize the training. It stops the model from just learning to copy paste the suit's results. Instead, it forces it to actually reason with the information it found.
I see. Prevents a common shortcut or pitfall.
Exactly. And the reward system is also pretty robust. It's rule-based. It uses exact string matching to see if the answer is correct. They deliberately avoided using more complex, neural reward models.
Why is that? Too unpredictable.
Yeah, those can sometimes introduce instability or even lead to reward hacking, where the model figures out how to get the reward without actually doing the task properly.
Right.
Gaming the system.
Precisely.
Right.
So by the end of this RL stage, the LLM is just significantly better at complex reasoning and at dynamically pulling in outside information when it needs it.
Okay, so RAG-R1 builds this really impressive foundation. Stage 1 teaches it how to think and retrieve methodically. Stage 2 refines that with RL. But you mentioned that bottleneck earlier, the single query mode.
Mm-hmm.
The research suggests RAG-R1 tackles this head-on with something that sounds like a real game changer. Multi-query parallelism. How does that work? Why is it such a leap?
Yeah, this multi-query parallelism is, it's pretty clever. Basically, it guides the LLM to generate multiple search queries, up to 3, actually at the same time, whenever it decides it needs external info.
Multiple queries at once. Yeah. Simultaneously. And then the external retrieval system goes and performs parallel searches for all those queries, gets the results, and sends them back in a structured JSON format, which clearly links each original query to the documents it found.
Wow. Okay. Doing things in parallel. That just fundamentally changes the speed, right? So if it's getting more info faster, what are the practical benefits for, someone using this? What did the findings show?
The benefits are really significant. First off, speed. This approach drastically cuts down the total number of back and forth retrieval rounds needed.
Fewer steps.
Way fewer steps. And while each individual retrieval takes about the same amount of time because you're doing fewer rounds overall, the result is an 11.1% decrease in total inference time compared to the best previous methods.
That's a noticeable difference.
It is. But it's not just speed, it's also about depth. Because it's generating multiple queries in parallel, the model gets much more comprehensive, more diverse information in just one interaction.
Ah, okay, so better context.
Exactly. This is especially good for questions that require comparisons, for instance. It genuinely broadens what the model can handle.
Let's get concrete. Can we dive into some examples from the sources? I think that really helps illustrate it. There was one about magazines. Which magazine was started first, Arthur's Magazine or First for Women?
Right, good example. So in the old single query way, the LLM would first have to search for, say, founding year of Arthur's Magazine.
Okay, step 1.
It gets that back 1844 to 1846. Then it thinks, okay, I need the other one, so it does a second search. Founding year of First for Women magazine.
Big tip.
Gets that back 1989, apparently. Then finally, it can compare the two dates and give the answer. It's sequential.
Got it. Step by step.
Now, with multi-query parallelism, the LLM thinks, okay, I need to compare founding years, and it immediately generates 2 queries in parallel. Arthur's Magazine founding year and First for Women founding year.
Both at once.
Both at once. In a single retrieval step, it gets back both dates, 1844, 1846, and 1989. And bam, it can instantly see Arthur's Magazine was first.
Wow. Okay, that's way more efficient. Gets the right answer much faster. Fewer steps.
Clearly demonstrates the efficiency gain. Saves a lot of time.
Okay, that's a great example of speed.
Yeah.
But you also mentioned it expands capabilities.
Yep.
The research had another case study, something about dictyosperma and hornia. That seemed to show something more fundamental.
Yes, exactly. This one really highlights the capability expansion. The question was, are both dictyosperma and hornia described as a genus?
Okay, a biological classification question.
Right. So the single query model, it searches for dictyosperma genus, gets some info back. Then it searches for hernia genus, finds out, yes, that one is a genus.
Okay.
But then when it tried to go back and confirm dictyosperma's status, it kind of struggled. Even after doing more searches, one by one, it couldn't find clear enough evidence. And eventually it just gave up and answered no.
So it hit a wall, couldn't find the info it needed that way.
Exactly. It hit a limit. It was like, going down a rabbit hole on the web and just not finding that crucial piece of confirming evidence. Frustrating.
Been there. Okay, so how did multi-query handle it?
Well, the multi-query model immediately sent out 2 parallel queries, dictyosperma genus and hernia genus.
Okay.
It got some initial documents back for both. Now, crucially, even if that first batch of parallel results wasn't totally conclusive for, say, Dictyosperma, the multi-query approach allowed the model to use all the information it had gathered so far, the partial info, to formulate new, more refined queries for another search round. Still in parallel.
So it could use the partial answers to ask better questions next time.
Precisely. This ability to integrate that partial information and then conduct another targeted multi-query search if needed, that's what the SORC highlights. It allowed the model to successfully find the evidence confirming that both are indeed described as genera. So it got the correct yes answer.
So it didn't just get stuck. It could adapt its search based on everything it learned in parallel.
Exactly. This isn't just about being faster. It's a clear case where multi-query parallelism actually expanded the model's ability to solve a complex question that the single query approach just couldn't handle. It pushed the boundary.
That's really compelling. Okay, the examples make sense, but the ultimate test, as always, is performance across the board. The research included benchmarks, right? What do the numbers actually tell us?
Yeah, the proof is in the pudding, as they say. The experiments were run across 7 different question-answering benchmarks covering various types of questions, and the results. RAG-R1 Mellow-Q, that's the multi-query version, consistently outperformed all the baseline methods. That includes both general QA and the trickier multi-hop QA tasks.
Multi-hop meaning you need to connect several pieces of information.
Exactly. Questions that require multiple reasoning steps. And specifically, it beat the previous strongest RL-based method, which was called R1 Searcher, by up to 13.2% across all the data sets they tested.
13%. That's a pretty significant jump in this field.
It really is. It clearly shows how well this whole approach, the two-stage training plus multi-query, enables the model to effectively blend its internal knowledge with dynamically retrieved external facts. Higher accuracy.
And it wasn't just about raw performance on those specific tasks, right?
Yeah.
The sources mentioned something about adaptability.
Absolutely. This was quite remarkable, actually. Even though the models were only trained using a subset of just one training dataset,
Okay.
they showed excellent generalization capabilities when tested on completely out-of-domain datasets covering topics they hadn't explicitly trained on.
So it learned the skill of reasoning and retrieving, not just facts about one topic.
That's the key takeaway. It learned to reason adaptively, to retrieve information effectively for a wide range of questions. This really proves its potential for various real-world scenarios where you need that deep, flexible information retrieval. And just quickly, the ablation studies where they test the system with different parts turned off confirmed everything we've discussed.
Right, testing each piece.
Yeah. They showed that the SFT stage for learning the format, the RL stage for refining the reasoning, and that careful data selection for RL, all of them are crucial. Each piece contributes significantly to the model's overall superior performance and, importantly, its stability during training. It's a well-engineered system.
Okay, so putting it all together, what does this RAG-R1, especially with multi-query parallelism, mean for you, the listener? It seems like it represents a real leap forward in how LLMs can find and use information. It sounds like it translates to getting, more complete, more diverse answers and getting them faster.
That's the core benefit, yes.
Which could really help cut through that feeling of information overload and help ensure you're actually getting genuinely well-informed, even on complex or nuanced topics. It sounds like it delivers a deeper, faster understanding.
I think that's right. And this ability for LLMs to dynamically, efficiently run multiple searches in parallel and then weave all that comprehensive information into their reasoning, it really does open up some fascinating possibilities for how we interact with knowledge systems in general, which maybe raises a bigger question for us to think about. How might this kind of enhanced adaptive knowledge retrieval fundamentally change the way we interact with complex information in the future? Could it allow us, to tackle even more multifaceted problems that currently just overwhelm our standard search tools or even today's AI?
That is a truly provocative thought. Where could this lead? Well, thank you for joining us on this deep dive into RAG-R1. We hope you feel a little more well-informed and maybe a lot more curious about what's next in AI. Till next time.